Welcome to The Explainer. Today, we're looking at a brand new AI model that's turning a core belief in artificial intelligence completely on its head.
For years, the answer to that question has seemed pretty obvious, right? If you want more power, you just build a bigger model. More data, more parameters, more compute. It's been a simple formula. And that simple formula has kicked off this massive arms race. All the tech giants are building these colossal models, each one bigger and badder than the last. But what if that's not the only way forward? What if there's a smarter way to do this?
Yeah, this whole bigger is better thing, it comes with some serious downsides. This endless race for scale has a really hefty price tag, and it's created what you could call AI's heavyweight problem.
Okay, so these giant models, they are incredibly expensive to train and run. We're talking about just massive amounts of computational power. And that basically locks out smaller companies, independent researchers, pretty much anyone who doesn't have a mega budget. It creates this huge bottleneck for innovation where, only the biggest players can even get in the game.
So all this has created this perception, this idea in the industry that small models just can't hang, that they simply don't have the horsepower for complex stuff like generating and editing images from really tricky prompts. But what if that whole idea is just wrong? All right, so let's get into it. Meet DeepGen 1.0. This is a brand new model from a team of university researchers, and it was designed from the ground up to prove one thing, that a smart, efficient design can totally beat raw brute force scale.
And when I say size difference, I mean it's enormous. Just look at this. In one corner, you've got a heavyweight champ clocking in at 80 billion parameters, and in the other corner, our challenger, DeepGen 1.0, at a teeny tiny 5 billion. So here's the thing. DeepGen isn't just small, it's also this unified all-in-one system. It packs this incredible range of abilities. We're talking image creation, complex reasoning, text rendering, editing, the whole shebang, into a package that is 16 times smaller. Seriously, how is that even possible?
Well, the secret isn't just throwing more power at the problem. It's about a smarter architecture. The entire system is designed for just maximum efficiency, to squeeze the absolute most out of every single parameter.
At the very heart of this is a new technique called stack channel bridging, or SCB for short. Now, you can think of it like a super efficient communication system. It completely changes how the two main parts of the model talk to each other.
So this SCB technique, it connects the vision language model, that's kind of like the brain that understands what you're asking for, to the diffusion transformer, which is the artistic hand that actually creates the image. Now, instead of just one narrow little connection, SCB builds this wide, multi-lane bridge with multiple connection points. And this is key. It preserves both the big picture ideas and all those tiny, fine-grained details that other models just tend to lose along the way.
And that's not all. To boost its reasoning power even more, DeepGen uses something really clever called think tokens. It's basically like giving the model its own internal notepad, a little scratchpad to work through a complex problem and map out its chain of thought before it even starts to draw anything. Pretty cool, right?
Okay, so a smart architecture is one thing, but that's only half the story. You also need really smart training. And DeepGen's power comes from this super efficient three-stage training plan. Think of it like a training camp for an AI athlete.
It's this really progressive process. So first, it starts with basic alignment, just getting that brain and hand to work together. Then it moves on to this advanced fine-tuning on a huge mix of high-quality data to build all these versatile skills. And finally, it finishes up with reinforcement learning, which is all about polishing the final results to make sure they align with, what we humans actually like to see.
And the variety of this training is what's so incredible here. It's not just being fed simple image-text pairs like a lot of other models. No, it's being trained on literally everything from simple image creation to super complex reasoning and editing tasks. And that is what gives it what the researchers call its omni abilities, basically the power to handle almost any visual task you can throw at it.
So the big question is, does this whole David versus Goliath strategy, this smart design and efficient training, does it actually work in the real world? Well, the performance data is, frankly, it's stunning.
All right, let's just revisit that matchup for a second. We have the tiny 5 billion parameter DeepGen going up against the 80 billion parameter giant. That's a 16-to-1 size difference. It's not even close in terms of scale.
And yet, on complex reasoning tasks, which are measured by something called the WISE benchmark, the much, much smaller DeepGen actually outperforms that giant by a remarkable 28%. That's not just, oh, it's competitive.
That is a decisive win. And it's not a fluke either. In a reasoning-based image editing, it absolutely demolishes another model, one that's over 5 times its size, beating it by a massive 37%. Think about that. It's completely dominating in the exact areas where we all thought smaller models were supposed to be weak.
So, what does all of this mean for the future of AI? And, why should you even care about this?
Well, what this breakthrough really shows is that we can finally separate AI power from just massive brute force scale. It opens the door for AI development that's way more accessible and sustainable. This means more researchers can actually get in and innovate, and it paves the way for powerful AI that can run right on your laptop or your phone, maybe even in your car, without needing to be hooked up to some giant data center all the time.
Really, the biggest takeaway here is that smart innovation in design can be way more powerful than just throwing more and more computing power at a problem. It's a huge shift from that brute force approach to a more elegant, more efficient way of thinking.
And that leaves us with a really fascinating final thought, doesn't it? If smart design can beat raw scale this convincingly, it kind of proves that the next big idea in AI doesn't have to be big at all. In fact, it might just be small.